Hi everyone, and welcome to this video where we're going to look at derivatives of logarithmic functions. So if you'll recall, in the last video we looked at derivatives of exponential functions. And exponential functions and logarithmic functions are inverses of each other. The derivative of log base a of x is equal to 1 divided by the natural log of the base a times x. So it's the reciprocal of the product of the variable and the natural log of the base. Then we have the derivative of the natural log of x. And this is just 1 over x, okay? And the reason is, if you think about it, the natural log of e is 1, right? So e and ln are inverses of each other. So therefore, 1 divided by the ln of e of x, if we use the rule above, this one here, the ln e part just turns into a 1. So it just goes away, right? And you're just left with 1 over x. Okay, so two important logs, derivatives to remember. So let's say I want to find the derivative of y equals the log of x. So the derivative of y with respect to x is just going to be 1 divided by the natural log of the base. Well, the base is not written there. And if it's not written there, it's understood to be 10. So we call that a common log. So there's an invisible 10 right there. That would be your a, and then it's times x. And that is all in the denominator. For b, I have y equals 7 times the natural log of t. So the derivative of y with respect to t is just 7 times the natural log of t, which I know is just 1 over t. So we just get 7 over t. Take a minute and practice one on your own. Next, let's look at the derivative of the log base a of g of x and the natural log of g of x. So here, the derivative with respect to x of the log base a of g of x is just going to be 1 over the natural log of a. And then we're going to multiply that by the derivative of g of x divided by g of x. Okay, and similarly, if we want to find the derivative of the natural log of g of x, that's just going to be g prime of x over g of x. And remember, this would just go away, right? That's why it's not there, because it's really the ln of e, which is 1. So it would just turn into 1 over 1, which would just leave you with this. Okay, let's look at an example. So we want to find the derivative of the natural log of 6x. So first of all, my g of x is just going to be the 6x. And we know that using the power rule, the derivative of 6x is just 6. So if I want to find the derivative of f of x, it's just going to be 6 divided by 6x, which is just 1 over x. Okay. And here I have f of x equals the ln of x squared plus 1. So again, g of x is x squared plus 1, and g prime of x would just be 2x. So if I want to find the derivative, again, I've just been using this formula here, since we're dealing with ln. It's just g prime of x over g of x. And that's it. Now in letter C, I have a log, so I'm going to need to look at this first formula here. Okay, so here I've got g of x, which is 3x squared minus 4x. So using the power rule, g prime of x would just be 6x minus 4. So if I want to find the derivative of y with respect to x, it's just going to be the 1 divided by the natural log of the base. The base here is 2, right? And then we're going to multiply that by the derivative of g of x, which is 6x minus 4, and then over g of x, which is 3x squared minus 4x. Okay, and of course I can combine that and just write it as 6x minus 4 over the natural log of 2 times 3x squared minus 4x. Here's a couple for you to try on your own, and again, when you have completed that, we can move on to our next derivative rule. So here we have the derivative of the log and the natural log of absolute values. Okay, and this should be the absolute value of x right there. All right, so let's write down a couple rules here, which you're going to see very, they're going to look very familiar. So the derivative of log base a of the absolute value of x is just the same as the derivative of the log base a of x. And that's just going to be 1 divided by the ln of a times x. Okay, and the x is in the denominator. Then you've got the derivative of log base a of the absolute value of g of x. And that's just going to be, again, 1 divided by the natural log of a. And then I'm going to multiply that by the derivative of g of x over g of x. Okay, very similar to using this formula right here. So notice they're the same. And then I have, excuse me, the derivative of the ln of the absolute value of x. And that's just 1 over x, which is the same as the derivative of the ln of x. And last but not least, I know this is not going to shock anyone, the derivative of the ln of the absolute value of g of x is just g prime of x over g of x, which was the same as the natural log of g of x. So those formulas are the same, right? We've got these two here, which are the same as the first two we learned. And then you've got these two here, which are the same as those two. So the absolute value makes no difference on finding the derivative if you see expressions written with absolute values when taking the log or the natural log. All right, so let's say we have to find the derivative of y equals the natural log of the absolute value of 5x. So what rule am I going to use? Well, I'm going to use this rule, right? Natural log, this rule, because you have the natural log of g of x. So g of x here we know is 5x. Okay, let me slide this down. So that tells me its derivative would just be 5. So all I need to do is take g prime and divide it by g of x. And again, you just get 1 over x. Okay, now for b, we've got 3x times the natural log of x squared. So that we have a product here. We're going to have to use the product rule. So I'm going to let u equal the 3x, and v is going to equal the natural log of x squared. Okay, so for u prime, we know it's just going to be 3. For v prime, I'm just going to have g prime of x over g of x. So, g of x is just x squared. G prime of x would be 2x. So this is just 2x over x squared. Okay, I'm going to leave it like that. Now remember, the product rule says u times v prime plus v times u prime. Okay, so to find the derivative of this function, 3x times natural log of x squared, it's going to be u times v prime plus v times u prime. So now if I multiply these two expressions together, I would get 6x squared over x squared, which just turns into 6. And then I have plus 3 times the natural log of x squared. Remember, you can't multiply these two things together because you're taking the natural log of x squared. X squared is the argument. It's 3 times this. Now, another way you could write this, if you remember your log rules, there's a rule that takes the 3 and moves it up with the squared part. So you can also write this as 6 plus the natural log of x to the 2 times 3 power. And that would just be 6 plus the natural log of x to the 6th. Okay, and that's using what's called the power rule for logs. So that's just another way you could express your answer, and it's still the same thing. All right, take a minute and pause the video and try practicing using those rules. All right, our last example. So here we're finding the derivative of each of these functions. Okay, first one we have is f of x equals the natural log of x squared times e to the x. So we can use the log rules to rewrite. Otherwise, you would need to use the chain rule and the product rule. So let's do that first. So again, this is good review of your log rules. I have the log of a product, which we can rewrite as a sum. So I can rewrite that as the log of x squared plus the natural log of e to the x. And using my product rule for logs, the 2 can come down in the front, just like the x can come down in the front. And if you'll recall, the natural log of e is 1. So all you're left with is 2 times the natural log of x plus x. And now, if I want to find the derivative of that, 2 times the natural log of x. Well, if you remember the natural log of x, the derivative of it is just 1 over x. And the derivative of x is just 1. So our final answer is just 2 over x plus 1, which, if we rewrite that as a common denominator, it would just be 2 plus x over x, right? I can rewrite this as x divided by x. So it's just 2 plus x over x. In letter B, I've got g of x equals the natural log of x plus 1 over x minus 1 cubed. So similarly, I'm going to use my log rules and rewrite this first. Otherwise, like I said earlier, you have to use the chain rule and the product rule. So here we would have to use the chain rule and the quotient rule. So if I rewrite this, dividing logs is the same as subtracting the 2 logs. So I'm going to change this to the natural log of x plus 1 minus the natural log of x minus 1 cubed. Okay, and again, I can take that cube and put it down in the front. So I would have the natural log of x plus 1 minus 3 times the natural log of x minus 1. Okay. So let's identify our g of x and things like that. So if I want to find the derivative of g prime of x, right, you got the natural log of g of x and then another g of x. So I'm going to use the g prime of x over g of x formula. So if this is g of x, right, the derivative would just be 1. And we would divide that by g of x, which is x plus 1. So that's just going to be 1 over x plus 1. And then I've got minus 3 times, okay, if this is my g of x, g prime of x would be 1, and then it would be over g of x. So 1 over x minus 1. Okay, and then I would need a common denominator. So my common denominator would just be x plus 1 times x minus 1. Okay, I'm going to multiply this top part by x minus 1. So 1 times x minus 1 just gives me x minus 1. And then I have minus 3 times, I'm going to multiply this by x plus 1 over x plus 1. So I would just have 3 times x plus 1 there. So what I have is x minus 1 minus 3x minus 3 in the numerator. And then if I clean that up, I would get negative 2x minus 4 over x plus 1 times x minus 1. And that's it. And that brings us to the end of the video.